Hello everyone, this is a November 14 question, paper 1-1 and the question number is 30. This question is concerned with the chapter Hydrocarbons. The question reads, beta-carotene is responsible for the orange color of carrots. So look at this beautiful information. If beta-carotene, this strange looking organic compound would not have been present, we cannot deny the fact that carrots would somehow be looking like radishes. Although this statement is not backed up by any scientific evidence, this is what I hypothesize because imagine there was no orange color in carrots and carrot was just white. That means it would be hard to distinguish between carrots and radishes. Going back to the question, this is the weird looking compound beta carotene. Beta carotene is oxidized by hot conc acidified KMNO4. So whenever a question mentions about this hot conc acidified KMNO4, you should have a eureka moment. That means you should recognize immediately that this information relates to the fact that we are going to have to deal with alkenes for such questions. And indeed, there are lots of alkene carbon-carbon double bonds, God knows how many. Question continues, when an individual molecule of beta-carotene is oxidized in this way means oxidized by this method, many product molecules are formed. How many of these product molecules contain a ketone functional group? So we are only concerned with how many of these guys can produce a ketone functional group. And there is only one simple bit of information you need to have committed to your memory to solve this question or tackle this question successfully. That is, to form a ketone functional group, not only you have ketone functional group via oxidation by hot conc acidified KMNO4. You not only have to have carbon-carbon double bonds, but also you need to have an alkyl group denoted by R in the carbon-carbon double bonds, because if you do not have if that condition is not satisfied, you could either have carbon dioxide and water or carboxylic acid. So for ketone functional group to have out of this thing, you need to have a carbon-carbon double bond attached to an alkyl group R. So let's first count number of carbon-carbon double bonds, which are 1 2 3 4 5 6 7 8 9 10 11. Option D is 11. So you should immediately recognize that option D should definitely be incorrect, because they are not going to ask you such simple questions in exam. Although this is incorrect, we are going to overlook it for now. Ketone functional group means what I've said just now is we need to have an alkyl group attached with a carbon-carbon double bond. So let's see all the double bonds. We need not be concerned with the single bonds. We only need to look after the double bonds. So the maximum number of product molecules we can have is 11. We have one here. 1 year, so this qualifies because this double carbon double bond is attached to the side group R or methyl group. This does not qualify. This qualifies because we have double bond here and an alkyl group here. This does not qualify. This qualifies, same reason. This does not qualify. This qualifies because we have double alkyl group here, methyl group. We have 4 so far. This does not qualify. This qualifies, same reason. This does not qualify, and this qualifies because of the presence of methyl group. So if we count the total number of asterisks in this question, or I should have written it with the pound symbol, because asterisk is normally used to denote chiral carbons. We have 1 2 3 4 5 6 asterisks, making B 6 the correct answer.